Okay, in this lesson, we're going to be talking about histograms. So first of all, a histogram is just a graph of numerical data in which you can determine the frequency of each category by looking at the height of each bar that is represented in the graph. Histograms are really useful in order to determine the shape of the distribution, but we can also change what's called the bin width. So that can drastically affect how a distribution looks. So when you're selecting a bin width, you want to make sure that it is not too large, but not also too small. Okay, so if we take a look at some graphs, this is actually the same set of data that has just been represented by different histograms with various bin widths. So we see a very large bin width for this first one. The data ranges from 0 to it looks like 50. And we can see that, okay, those are high frequency, and then the second interval that goes from 50 to 100 is very minimally represented. The frequency is very small for that interval. So that is probably a little bit too large of a bin width to use for that distribution. It doesn't really represent the data well. This next one, we can see more of a shape of the distribution. We can see that the interval from 0 to 10 is much more frequent than from 10 to 20 or 20 to 30. Or even to all the way to 50. So this interval from like 20 to 50 was barely representing the distribution, whereas this one, it looks like there's even distribution from 0 to 50. And we can see that in this one, 0 to 10 is a much more frequent data in that distribution. And then this one down here, again, we can see a little bit more of an explanation. This first width, it looks like it's going from 0 to 5. And again, that is more frequent than 5 to 10, so on and so forth down the line. And then this one, although we can see more of the data and which numbers are more frequent, it might split up the data a little bit too much. So this might be a little bit too descriptive. So those are just some examples of varying bin widths. Okay, we can also talk about whether the distribution has a single mode. We say unimodal. If it has two modes, bimodal, or multimodal if it's more than two, or if it's just uniform across the board. So if we take a look at our examples, this first one, if we were to just draw a smooth curve over top, even though there is a little bit of a dip right here, we probably would just go right over that dip. So we would call this one unimodal. This one definitely has more than one peak. So if we were thinking about smooth curve over the top of those, we can see that it peaks twice. So we would say that this one's bimodal. This one, it starts off with a little bit of a peak, and then it has, again, maybe more than two, so maybe three peaks. So we would say this is multimodal. And then this one, even though there are some differences in the frequencies of those classes, it's pretty much staying at this same level the entire time. Maybe a couple of exceptions, but again, we would just say that this one's more uniform. Okay, we can also tell the shape of a distribution from a histogram. So again, if we think about drawing a smooth curve over top of our data, with this first one, we have a peak at the smaller values. So maybe from 0 to 4 is where the peak is, and then it trails off slowly to the right. So we named the skews by the longer tail. So this is a right skewed graph. This one here, if again we draw a smooth curve over top, We can see that the peak is more towards the right side and that tail is drawn out to the left. So this one's a left skewed graph. And then this one here, if we draw a smooth curve over top, kind of looks like both sides are approximately the same. So we would say that this one is symmetric. So note, we do name the skews by the longer tail. Okay, an outlier is a data value that is very different from the rest. So in this first distribution, most of our data is in the smaller range, again, from like 0 to 5. We do have a couple values here, but notice this large gap in between. And then we have maybe one or two data values way out here. So this would be considered a potential outlier because these are very large in comparison to the rest of the data. Over here, again, same kind of thing is happening. We have more of a symmetric distribution, and then we have a gap, and we have a few values out here on the right side. So there may be an outlier, but an outlier is an extreme difference between them. And the fact that there's, I don't know, maybe 3 or 4 data values out here, there's a smaller gap in between, and then this one is more symmetric. These are potential outliers, but they're probably just unusual observations and not technically outliers. So we are going to have a little mathematical check that we're going to talk about to identify outliers. But for right now, you just want to see if a data value is very small or very large compared to the rest, then we could say it's a potential outlier. And we'll get into how we actually check for outliers a little bit later. Okay, so we're just going to practice identifying some shapes of distributions. So again, if we draw that smooth curve over top, oh my, if I could draw a smooth curve, that would be wonderful, right? Here we go. Okay, so think about what skew that would be. Most of the data is on the left side. The right tail is drawn out. Hopefully, we're thinking that that's a right skew. So remember, we name them by the longer tail. Okay, we talked about our modalities. The unimodal is just a single peak. We could have 2 peaks. That would be considered bimodal. If we have more than 2, we tend to just call it multimodal. Or we have what's called a uniform distribution. Okay, we talked about skewness. So a distribution could be right skewed, a longer right tail. A distribution could be left skewed, a longer left tail. A distribution could be symmetric if it's the same on both sides. Okay, so this little practice activity, we want to just determine which one do we think would be uniformly distributed. Weights of adult females, salaries of a random sample of people from North Carolina, house prices, or birthdays of classmates. Okay, so let's think about each of these distributions. So if we think about the weights of adult females, we're going to have some people are underweight, some people are overweight, and probably a majority of people are going to be in the middle. So I would anticipate that weights of adult females would probably be pretty symmetric. Salaries of a random sample of people in North Carolina. So if we think about salaries, we probably have more people on the lower end than the people who are making millions. So our distribution is probably right skewed. For C, house prices. Again, I would anticipate that house prices, there's more in the lower level, and then there's some very expensive multi-million dollar homes. So I would anticipate another right skew. Birthdays of classmates. If we're talking about day of the month, we're probably, if we were to take a sample, we probably would have the same number of people born on the 1st as born on the 2nd, all the way through born on the 31st. So that one is the one that we anticipate is going to be uniformly distributed. Okay, this concludes our lesson on histograms.